Okay, 2.4 chain rule. This is another rule that you need to get on that derivative sheet. Maybe tomorrow I need to make sure you got it going. So the rules we have so far is the basic rule. What's the basic rule? So d dx of cx to the n would be c times n x to the n minus 1. Yes?
Oh, we can do that.
Okay. I just put the basic and the coefficient one together because it's the same. Okay. And the product? Derivative of f times g is derivative of x, this is basically what it is, plus f derivative of g. Yes?
Yep.
Now, if you look in the book, it says derivative of f g plus derivative of g f. Does it matter? No. Okay. The quotient. So d dx.
It's the same thing except over g of x squared.
Minus.
Boy, out that too.
Okay, so it's f derivative of f times g minus f times the derivative of g all over g of x squared. Okay?
Yep.
So that's what we already know. When do we use a product? When there's two things multiplied. When do we use quotient?
Something's being divided.
When something's being divided. When do we use the basic?
When it's basic.
When it's basic. Okay? So when you take your test, if it is set up for the quotient, I will not allow you to divide out like you had to do on your quiz and do them individually. You have to use the quotient. Okay? Now, I do think maybe even on this test I say use the product, use the quotient. I'm not 100%. If I do have those, there's certain ones I say do it, and then there's ones I say just find them. So you have to decide. Okay, so without the chain rule, with the chain rule, this is just examples. Okay, without the chain rule, I can do x squared plus 1. With the chain rule, I can do the square root of x squared plus 1. What's the difference between these two?
One of them got rid of the squared. The one is square root.
Don't I have a function in a function? Because that's a function, yeah? Right there?
Yep.
So I have
Different things for me.
I have a function in a function, right? Where this one, I just have one thing here and one thing here. They're not tied together. So I can find the derivative of sine without the chain rule, but if I have sine of, and I hate it when they do this, this is sine of 6x. Do I have something in sine other than x?
Yes.
Yes. So that would cause me to use the chain rule. So on the left, I have 3x plus 2, but on the right, I have 3x plus 2 to the fifth. So I have that fifth on the outside that has put a function in a function. So this is basically f of g of x, where f of x is x to the fifth, and g of x is 3x plus 2. Does that make sense? Okay. So on the left, x plus tangent, we're good. We can do everything we did. But what's wrong with this one? First of all, they wrote it. Well, if I do this, I think you can see what's going on. Not make a difference in your brain? Doesn't mine.
With the parentheses?
Yeah. So f of x is tangent of x, but g of x is x squared. x, not just x. So if we look at the first one, what's my f of x?
Well, you just confused me.
What? Well, the trig ones are kind of. We have
Well,
f of
because
g
I thought
of x.
the first one is f. How did you get the tan with the...
The tangent. Well, this one is all by itself. That's just all by itself.
Yeah, so why
So
did you
that one we would do at normal. That's 1. That derivative is 1. Then we have to do the derivative of this,
Okay.
where this comes in
So
play.
you just didn't put the 1.
Right.
Okay.
Because I wasn't talking about that. I'm talking about the in and the outside. Because we will be able to and have to incorporate these rules together. Like you'll have to do a product with a chain. Sometimes you do 2 chains, a product and a quotient. It just depends on what the problem has in front of you.
Can we go back to the multiplication table?
So on the very first one, what's the outside function? The square root. So f of x would be the square root of x, and g of x would be the x squared plus 1. Do you see the function in the function?
Yep. Yeah, you just separate.
Right. This one, again, put your parentheses. They don't, and it makes it hard. Because f is sine, and g is 6x. Okay? We have to know what is f and what is g. We have to know the inside function, and we have to know the outside function. Got me? Okay, so red box comes directly from the book, so we only write down what makes sense, right? Okay, I will explain it all, but only write down what makes sense. So if y equals f of u is differentiable function of u, and u equals g of x is differentiable. So both functions have to be able to be found the derivative. Remember, we can find the derivative as long as it's not discontinuous at that point. Yes? Then f of g of x is differentiable function. So if I can differentiate 2 functions on their own, when I combine them in any way, whether it's addition, subtraction, multiplication, division, or composite, am I also able to find the derivative? Yes, because basic is addition, subtraction, multiplication is product, division is quotient,
Yes.
and this is composite. So if we have dy dx equals dy du dx, this equals this. Now, that might not mean anything to you right now, but hopefully down at the bottom does. So the derivative of f of g of x, composite, is the derivative of f with g in it times the derivative of g.
Can I just write the bottom one?
Yep. This is what I will write. So up at the top, when I found f and I found g, that's why this is important. It's the derivative of the outside times the derivative of the inside. Derivative of the outside with the regular g in it times the derivative of the inside. Everyone got it written down?
Yep.
Ainsley, got it? Okay. Okay, so what is the outside function? What's f? X cubed. And what's g? 3x minus 2x squared. So our rule is f prime of g of x times g prime. And what does prime mean? Derivative. And this happens to be g, but f is the outside, g is the inside. Got it? Okay, so g prime of x. Okay, so what is the derivative of x cubed?
3x. yeah, 3x squared.
Okay. What goes in here? Just g. So the 3x minus 2x squared times the derivative of the inside. So what's the derivative of 3x minus 2x squared?
3 minus 4x.
I would write it, because I don't like putting that squared right there, I would write it like this. But other than that, are we done?
Yep.
Now, this can be used for multiple. Like the product could be used over and over and over again. Guess what? The chain can be used over and over and over. We can have a function and a function and a function and a function and a function. You start at the outside and work your way in.
Is it squared because you did the n minus 1?
Mm-hmm. Yep. Ready for another one?
C.
Okay, the biggest part is what's the inside and what's the outside. So, cube root, what exponent is cube root?
1/3.
1/3. So our outside function is to the 1/3? Yes. And my inside is x squared minus 1. So out, in.
What happened to like it being squared?
Oh, sorry. Oh, do we have a function and a function?
We have 3 of them?
We do.
No.
So what we have,
Did you simplify the last one?
there was nothing to simplify, I don't think. Oops, let me go back. Let me see. That was squared. I don't think I can see it. No, it was, you had, quit jumping. It keeps jumping. Stop. Okay, we had 3 and then a quantity squared. So unless you square this quantity, you can't multiply. So you're done. Okay. Okay, so now let's go back to this one. Now it's going to forget this. This is doing great today. Sometimes it won't change and other days it won't. Okay, so this is basically x squared minus 1 squared to the 1/3. Yes? Because 1/3 came from where? The cube root. Okay, so we're going to start on the outside and keep going in until we get to the middle. Got it? Okay, so 1/3 out front, right? And then everything that's in there. So x squared minus 1 squared to the negative 2/3. Okay, so now I have to go here. So that's another one, isn't it?
Yep.
So that would be 2, and then the inside, x squared minus 1, and then I'm going to put the first just so you can see it. And then it would be times the derivative of the very inside right here, which would be what? 2x. Now, there will be some simplifying here because of what? The negative 2/3. So since this is all multiplication, can I move some things down easily?
Yeah.
Yes. So the 3 is going to come down. Just a second. 3 is going to come down. And then we would have, oh wait, this would be 2 times negative 2/3, which would be negative 4/3. So x squared minus 1 to the negative 4/3. Not negative. Why is it not negative anymore? We put it on the bottom. And then on the top we have this. So 2 times 2 is 4x times x squared minus 1. And we don't have to rationalize it. We can leave that 4/3 on the bottom. And I need to write it better so it looks like an exponent.
2x squared minus 1.
What?
2x squared minus 1.
Yes. Oh, okay, so good question. This would be 3/3, yes? Because it'd be to the first? Yes? So I could reduce this and 3 of these. So I get 4x over 3x squared minus 1 to the 1/3. So sometimes you might have it right. It's just not simplified all the way down. And you're going to get better at the simplifying the more you simplify it. Okay? That is the quotient, not the quotient, the chain rule.